Okay, we're going to start this last part. We've got 4 problems left to do. The next problem is problem number 19. Problem number 19 says that your speedometer has an uncertainty of 2 kilometers per hour. So the delta A is going to be 2.0 kilometers per hour at a speed of 90 miles per hour. What is the percentage uncertainty? So with an A of 90 miles per hour, not miles, kilometers per hour. Let me check it here to make sure. Okay, it's 90 with no decimal, so it's one significant figure here. So the percent uncertainty is going to equal 2 divided by 90 times 100. And if you do that calculation, you get 2% uncertainty, one significant figure. The second part of the question says if the same percentage of uncertainty, if it has the same percentage of uncertainty when it reads 60 kilometers an hour, what is the range of speeds? So it's asking for delta A if A changes to 60 and this stays the same. And so we're looking for delta A now. And we remember the formula is the uncertainty is equal to delta A over A times 100. So delta A is going to equal the percent uncertainty times or divided by 100 times A. So delta A in this case is going to be 2% divided by 100 times 60, which in this case will give you an answer of 1.2 kilometers per hour. And actually, one significant figure, this changes to 1 kilometer per hour. And so the range will be 59 to 61 kilometers per hour. 59 to 61 kilometers per hour. Now, number 22 is the next problem. What is the area of a circle that has a diameter of 3.102 centimeters? Now, this is a question, not so much of geometry, but a question of how you're going to express these significant figures here. So, area is equal to pi r squared, which is equal to pi. Now, pi can be done out to as many decimals as you want, so it never controls how many significant figures there are. And then your 3.102 is squared. And remember, that's just like saying 3.102 times 3.102. So this has 4 significant figures and 4 significant figures. So the answer is going to be in 4 significant figures. So you get an answer out of your calculator that looks something like this. And then you see that you want to go to 4 significant figures, and this is less than 5, and so this is dropped, and the answer is 7.557 square centimeters. 7.557 square centimeters. Number 29, and this is an approximation. It says, how many heartbeats are there in a lifetime? Now you got to make an assumption here because, and I think we actually did this as a quiz question, but we have to assume that the average person has 70 beats per minute. And if you make a different assumption on your homework, I will not count off. And that there are 70 years in a lifetime. Now, obviously, if you make different assumptions about what a lifetime or how many beats per minute there are, like when they did this, they said that they said some different assumptions in the book. Now, let's just take 70 beats per minute, and we'll say that there are 60 minutes in an hour, 24 hours in a day and 365.1525 days in a year and 70 years in a lifetime. And if you do all that calculation, you get 2.57 times 10 to the 9th beats. And actually, as an approximation, you should probably just say 2 or 3 times 10 to the 9th beats in a lifetime, and you'd be perfectly all right. Okay, the last problem. The last problem is number 32. And number 32 states, calculate the approximate number of atoms in a bacterium. Assume that the average mass of an atom in a bacterium is 10 times the mass of hydrogen. So first it's telling you that the average atom has 10 times the mass of hydrogen. And it tells you that the mass of hydrogen is 1 times 10 to the minus 27 kilograms. So that means the average mass in a bacterium is going to be 1 times 10 to the minus 26 kilograms. So the average atom, so there's going to be 1 times 10 to the minus 26 per atom, per average atom. And the mass of the bacterium is 1 times 10 to the minus 15 kilograms. So actually this is quite simple. You take the mass of the bacterium and you divide that. Okay, that's the one bacterium is this many, and then one atom is 1 times 10 to the minus 26. And when you divide, you add the inverse sign, so you're adding 26 to that, so it's going to be 1 times 10 to the 11th atoms. And it's basically, that's it. Okay, so that finishes up our homework for this week. And every week I'm going to try to do this. If for some reason, because of my schedule or whatever, I can't, I will send out written answers to the homework problems that you can use. You just won't be able to do the video of it. The other thing I'll tell you is, remember, there's a help session this week, Friday the 21st at 4 o'clock.